Hello and welcome to Calculus video number 2. Today in class we looked at something called local linearity. So I wanted to go over a few of the main topics and ideas for that. We also looked at the slope at one point, slope at all points, which makes a function, and then making sure you can keep that those two functions separate, f and f prime. All right, so first, again, local linearity is the idea that if you take a function and you zoom in, it will become a straight line, no matter how curvy it is. So if I take this function and I zoom into a really curvy part here, you can see that already we basically have a straight line. And because we have a straight line, we can find the slope of that linear line using the slope formula to approximate the slope at one point. So let's do that. Find the slope at one point. We're going to take a look at the function x squared minus x minus 2. So to start off, we're going to find the slope at x equals 1. And so we're going to find the slope between 2 points. So the 2 points are going to be 1 comma something. And then another point really close to it, and I'd always say just add 1 penny. So 1.01 comma something. All right, just got to plug those into the calculator, and it will give you the y values. So you can see I already have them plugged in here. When you plug in 1, you get -2, and when you plug in 1.01, let's round that to -1.99. If your numeric view for the calculator here does not look like this, you can make it look like that. Hit Shift number, and under number type, if it says automatic, it will put all numbers in there for you, but they may not be the ones you want. So click on build your own. Hit numerical, and there it is. Again, to plug in the equation, you go to symbolic view and you type in your equation x squared minus x minus 2 there. All right, but we've got our y values here, and so we can simply put those in. -2 goes there, and -1.99 goes there. And now we simply find the slope between those 2 points. So subtract the y values. And subtract the x values. And so on the top, -2 minus 1.99 is -0.01. And on the bottom, 1 minus 1.01 is also -0.01, which is equal to +1. All right, so the slope when x equals 1 is 1. Let's do another one. Let's do x equals 2. As you can see, I've got those in the calculator already for us. So again, we would need 2 points, 2 comma something, which you can see is 0. And then 2.01, it's a number really close to 2, so I added a penny, and we get 0.03. So we do the slope formula for that. Subtract the y's, and subtract the x's. Oops. Because my interval was the same, the bottom is the same. And the top is -0.03, which you can check it on the calculator if you need to, but that is 3. So our slope is 3. So that's how you can find an estimate for the slope at 1 point. All right, going back to our outline here. we found the slope at one point. We also need to recognize that if we did that infinitely and we found the slope at all the points, it would create a new function. So let's take a look at that one. Okay, so here is our parabola again, x squared minus x minus 2. And we just found the slope at two of those points. So we have this function, f of x is equal to x squared minus x minus 2. And then we found the slope, and what we do is to call the slope is we call that f prime. It's called the derivative. And we found the slope at 1 first, and that was equal to 1. And then we found the slope at 2, and that was equal to 3. All right? So these are called derivatives. Or the slope at 1 point. And if you want to see what that means visually, if I go to the point at x equals 1, this one, as you can see, the slope, the angle is 1 over 1. It's pretty darn close, especially if I draw a dashed line here with a 1 over 1 slope. You can see it matches it pretty well. And then over here at 2, this slope is now different. It's much, much steeper. And it should basically approximate a slope of 3 over 1. So if I go up 3 and over 1, you can see that slope sort of matches up there with the angle of the curve pretty well. Well, if I did that over and over again, as you can see, there's a bit of a new relationship. We have an x and a y. We have an x and a y. It's a new function. And if you start graphing that function, so when I plug in 1, I get 1. When I plug in 2, I get 3. This is a new function, and if you kept doing it, you would get these points right here. You'll have to trust me on that. If you want to check the slope at those 2 points, you can. You would get this straight line here, a nice linear line. And so instead of doing this over and over again, the slope or the derivative at any number x is equal to that straight line. It's got a slope of 2 and a y-intercept of -1. And so this is our derivative function. All right, or a slope function. Okay, same thing here. Derivative and slope are the same. And this is where it gets confusing because we now have 2 functions, f and f prime. Are they related? Yes. Are they the same? Most definitely not. And so that brings us to our last point here. Let me erase everything for us. The difference between f and f prime of x. One of them is the value at a point, and the other is the slope at that point. So, 2 examples. If I have a function, f at 2 is equal to 5. That is telling me a point. So there is some function, and it goes to the point 2, 5. All right, that is a point. If I am told that f prime at 2 is equal to -1, that means the slope at that point will be -1. So what does a -1 slope look like? Kind of like that. Now the tricky part is f prime is a function of its own. So there is an f prime function at the point 2, -1. But it is a different function, a different equation. Do we know what the rest of this looks like? No, because I only gave you these two small pieces of information. All right, so we know the point is at 2, 5, and the slope at that point is -1. All right, if I take some of that away and I just tell you g prime at -1 is equal to 1/2, we only know the slope then. So the slope of the function g, we don't know what g is, but we just know the slope of g, the derivative of g. And we only know it at one point, at x equals -1. So the slope at that point is 1/2. I don't even know where that point is. So if I try to draw a graph, I know the x value over here at -1, but I don't have a y value, so I can't do anything else. But wherever that y value is, the slope would be 1/2. All right, hopefully that clears a few things up for you, and good luck with your homework, and see you next time.